in today's lecture, we will solve the examples based on LAMI'S theorem. But before that, we have to solve free body diagram. Now, what is actually the free body diagram and what is the solution? Without knowing the free body diagram, you cannot start the numericals, or without knowing the free body diagram, you cannot apply the LAMI'S theorem also. Okay, so let us discuss in this figure. You can see what is given in the figure. In the figure, it is given that there is a vertical wall. This is the vertical wall. Okay, and to this vertical wall, from the upper point, from this point, a straight string is connected at the center of this sphere. Center of the sphere is point C. Here, the angle is theta, which is the angle between the string and the vertical wall. So theta can be varied when the sphere is moved along with the wall or moved away from the wall. Okay. Now what is W? W is the weight of the sphere, which is always vertically downward. So remember two main things. What is that? This is the free body diagram. Now how to draw free body diagram? First of all, you have to find three concurrent forces which are acting at the center of the sphere. You can see at the center of this sphere, vertical weight W in the downward direction is acting. So this is the vertical weight W. Now when the sphere, if you move the sphere in the right direction and then after you will remove the force, then the sphere is going in the reverse direction. It will collide with the wall at this point, and the opposite force at this point will act in this direction. This opposite force or this colliding force is known as reaction of the wall. Okay, so this force is known as reaction of the wall. So from point C, this is the reaction of the wall going in the right direction. So these two forces are ready now. Weight W always in the vertically downward direction. Reaction. Remember my sentence. What is reaction? Reaction is always passing from the center of the sphere and always starting from the contact point. Okay, so here is the contact point, and from this contact point, reaction is passing from the center of the sphere. Last, third and most important thing, tension force. Whenever the string is there in the picture, then the tensile force due to weight of the sphere is acting along the upward direction or along the string towards the fixed point always. Okay, so this is the tension T towards the fixed point of the string. Clear? And the theta, if you draw, let us change the color. If you draw a vertical line like this from the center of the sphere, then this wall is parallel to this line. So this is the Z formation, and the this theta will be the alternate angle. So this is the theta, which is alternate angle. So here is the free body diagram completed. So what is free body diagram? If you want to define it, then for a given body, if supports are removed means what? Wall is removed, string is removed, and only forces acting on the center of the sphere are drawn. So forces acting on the body and support reactions are shown. The diagram so obtained is known as free body diagram. So here a wall is removed, sphere is removed, and the string is also removed. Now only the forces are available at point C. So this type of diagram is known as free body diagram. But W is equal to weight of the sphere, T equal to tension in the string, and R equal to reaction of the wall. So this is free body diagram. Now this type of free body diagram will be used while applying LAMI'S theorem. Let us see example number 1, which is similar to this. You can see the theta is now 30 degree, and what we have to find tension in the rope and reaction of the wall. So this is the tension T going upward towards fixed point, and the reaction of the wall will be passing from the point C. So this is the reaction of the wall passing from the center. This is the tensile force T, and this is vertical load 10 Newton. So this is the free body diagram. Now 30 degree angle will be drawn over here. If you draw vertical line, this is the wall line, then here it is 30. So Z formation will draw 30 over here. So remaining angle will be 60 with horizontal. You can imagine this. This angle is 90 degree. lower angle is also 90 degree. So now all the angles are ready with the help of free body diagram. So now these three forces means vertical weight downward 10 Newton, which is given in the data. Tensile force T is always acting upwards in the direction of fixed point of rope. This is the reaction of the wall R. Now we have to draw free body diagram that is completed. Now we have to apply LAMI'S theorem in this figure to obtain the required forces. Let us see how. See the same figure over here. Now for these three forces, 10 Newton, reaction R and tension T. Just apply LAMI'S theorem. Now what is LAMI'S theorem? If you take force T over here, then in the division, the angle should be opposite of force T. So this is the force T. Then the opposite angle will be 90 degree. So here it is T upon sine 90. Second force is R. So here it is R. Then the opposite force concentrate now. This is the reaction or resultant R. Then the opposite angle means in between the other two forces. So other two forces are T and 10. So this is the total angle, which will be 60 plus 90. So total will be 150. So sine 150 is there. And the last force is 10 Newton. Then the opposite angle means angle between other two forces will be 30 plus 90, which is 120. So 10 upon sine 120. Now you compare first with third, and then after compare second with third. You will get sine 90 equal to 1, sine 150 equal to 0.5 and sine 120 equal to 0.866 from your calci. Comparing one by one, you will get the answer of T equal to 11.55 Newton, means tension in the rope is now available, and reaction of the wall will be 5.77 Newton. So this is basic numerical for the LAMI'S theorem. Let us see one more numerical to understand the theorem. This is example number 4. What is given in this? An electric lamp in the street is having 50 Newton weight. So you can see this is the point B from which electric lamp in the street is suspended having weight 50 Newton. It is suspended by two wires of 4 meter and 3 meter length. So this is the wire which is having length 3 meter. This is another wire which is having length 4 meter. And from the ceiling, this is the ceiling AC. From this ceiling, two wires were suspended which is having weight 50 Newton. Now, the distance between two fixed points are 5 meter from which two wires were suspended. So this is the distance 5 meter from which two wires were suspended. Find out tension in both the wires. So we have to find tension in this wire as well as tension in this wire. So here it is tension T1, here it is tension T2. Okay, why the tension? Because in the string there is always tension towards the fixed point T1 and T2 as discussed in the previous numerical. This is the weight 50 Newton. Now how these angles are coming? Here the sides are 3, 5 and 4 meter. You can see the sides are 3, 5 and 4, means they are forming triplet, Pythagoras triplet. 3 square plus 4 square is equal to 5 square. It means 5 is the hypotenuse. So opposite of the 5, this angle will be 90 degree. Okay, so this is the right angle triangle. So with the help of trigonometry, what is tan theta 1? You can see this is theta 1. So what is tan theta? Opposite upon adjacent. So opposite of the theta 1 is 4 meter and adjacent is 3 meter. So it is tan theta 1 equal to 4 by 3, which is 1.333. Now what is tan theta 2? It is equal to again opposite upon adjacent. So 3 by 4. So 3 by 4 is equal to 0.75. So by doing tan inverse, you will get theta 1 equal to 53.12. And again by doing tan inverse, you will get theta 2 equal to 36.86. So these are the angles theta 1 and theta 2 respectively, which are drawn over here. Now how the angles are coming over here? Remember shortcut method. At point B, you just draw a horizontal line, which is this dotted line, horizontal line. Now, by doing this horizontal line, this ceiling will be parallel to that line. Now, with the help of alternate angles between two parallel lines, you can find that this is the Z formation. So, if this angle is theta, then this angle is also theta 2. This is theta 2, this is also theta 1. Similarly, reverse Z. This is the reverse Z. You can see, let us change the color. This is the green color Z. Okay, so this is theta 1, so this will be also theta 1. So theta 1 will be over here 53.12, which is calculated earlier, and this is theta 2 36.86, which is calculated over here. And the middle angle is 90 degree, which is in between T1 and T2 as shown in this figure, 90 degree. So now the angles are ready. Let us see how the LAMI'S theorem are applicable to find T1 and T2. Let us discuss in this figure. So now, if you take T1, then the opposite angle will be this 36.86 plus 90, correct? So it is sine 126.86. What is T2? So opposite angle of the T2 will be this 53.12 plus 90. So 143.12. The last force is weight 50 Newton. So opposite angle will be 90. So 50 upon sine 90. While you comparing this first with third, second with third, then the answer will be T1 equal to 40 Newton and T2 is equal to 30 Newton. So this is very simple numerical. In short, in this type of numericals, you have to understand the angles must. Angles are the technique which are applicable to LAMI'S theorem. If angles are not available to you, then the sum will be in trouble. So just practice these numericals. In the next lecture, we will discuss with some more numericals. Till then, revise this lecture. Thank you, students, and goodbye.